Welcome to the assembly of the Cherry 3D printer part 2. If you're just joining us, you should really watch part 1 beforehand, where we go through the electronic setup, including modification of the stepper motors to work with a ramps board, powering the ramps board from a 12-volt transformer, and flashing it with a firmware that will work with those motors. Part 2 is going to be all about getting the frame set up, but before we can get the frame set up, we're going to have to cut our smooth rods, we're going to have to position our parts, and we're going to have to do a lot of assembly on the parts, like installing our bearings, in order to be able to figure out exactly how everything's going to fit together. The purpose of this tutorial is to allow you to go with whatever size smooth rod you want so you can experiment. So I'm not going to be giving you exact measurements. Instead, I'll be showing you how to measure and put your components together so you can use any smooth rod you want. So let's jump to cutting the smooth rods first, and then we'll get into installing your bearings in the general assembly.
So the first step is to lay out your smooth rod, and then using a measuring tape, figure out where the halfway mark is on it. With the halfway mark isolated, all you need to do is use something like a pencil and leave a mark on the rod. The pencil is visible, but it will wear off easily, so you don't have to worry about damaging the smooth area of the rod. Next, you're going to need to cut the rod. You can use either something like a hacksaw, or you can use a rotary tool like I did. I recommend using this outside. It was raining on the day in question, so I made do with what I had. Also, make sure that you're wearing some eye gear, because these blades can split, and they're also throwing up metal, so you never want to catch any of that in the eye. Once you're done, you'll want to use something like a metal file or a sanding block on your rotary tool to smooth out the end to make sure it's got a nice smooth finish.
Well, with our smooth rods ready to go, now it's time to get into our components. Now, the one thing I can't stress enough is that you probably want to be able to get extra bearings, and the one thing you want to do before you start any of the assembly is test each of the bearings on one of your smooth rods to make sure that they move smooth. What you're looking for is any hard vibration or anything that feels like it's digging into the smooth rod, because if you've got locked bearings in here, they are going to scratch up the surface of this much quicker, and they're going to wear it right out, and you're not going to get nearly as much use out of your printer. So you just make sure they glide on there nice and easy. It doesn't feel like it's digging in or cutting, and just one at a time go through them all. I've tested the ones that I've got here, and they all run nice and smooth, so we'll go through. Now, if you only have 12 bearings and 1 or 2 of them are broken, there is a way to get around it and only build it with 10 of them. Essentially, when you go to assemble your hot end carriage, you can actually get away with just putting 2 in top and 1 in the bottom, because on the bottom only one of the bearings is going to make contact at any given time anyway, so a lot of the designs for the hot end carousel only have 1 bearing anyways. Likewise, in the y-axis for the bed, you can get away with just putting 1 in there as well, so 2 on one side and 1 on the other, but ideally you're going to populate all of them, so that's just a way to get around it if you end up with 1 or 2 dead bearings when you order your parts.
Now, bearing installation is pretty simple. When it comes to it, though, you're going to want to make it as easy on yourself as possible. So the bearings should not require a lot of force to push in. If they do, you're going to want to do a little bit of sanding. And you can use an X-Acto knife to just taper around the outer edge so that you don't have to really fight with it. This will also help if there's any sort of the elephant foot effect on the bottom of your pieces where it got smudged into the bed. So by giving it a little bit of a taper in, you should be able to line up the bearing a little bit easier. If the bearing can't go in at least a little bit by hand, you're going to have to assume that the part's probably a little too tight and sand it out a bit, because having a part that's too tight and then trying to hammer the bearings in will probably split it on the layer lines, which is going to be no good for you in the long run. It's going to really weaken the part. So with it lined up, you can use a mallet or a hammer, although if you're using a hammer, you're going to have to go light taps and just knock the bearing into place. Remember that the end of the bearings are pretty fragile, so never hit them directly with the hammer or you will release all the little balls that are inside. Now, with your bearings in place, go ahead and take a smooth rod and pass it through the bearings to make sure that it has no resistance. You should have absolutely no problem pushing it through from one side to the other, and the weight of the rod should be more than enough to make it move. You can test both sets of bearings just to make sure everything's nice and smooth. From there, you can repeat the exact same process for the Z-axis carriage. All you're going to have to do is line up the bearings, same as before, and tap them in using your hammer or your mallet against your piece of sacrificial wood. When you're finished, your bearings should be more or less flush with the plastic on your pieces, so just keep tapping until they're in all the way.
Now, with your bearings installed, it's time to get some smooth rods stuck into your Z carriage part so that we can start spacing everything out. So just take a set of your smooth rods And this is the only spot where you'd have a little bit of flexibility. If any of your cuts messed up and one rod's slightly shorter than the other, you can get away with using it here. Everywhere else, the rods need to be exactly the same length. In this case here, all you're doing is losing a little bit of your vertical size versus screwing up any of the squaring of your dimensions. So this would be the place to use your least properly cut rods if you have any bad ones. It's pretty much just line it up in place. Give it a couple of taps, and with these you can see how deep it's gone in. Ideally you want to get it all the way down into it, but you can use your own judgment. Obviously, as deep or the deeper it goes, the more axis you lose. So as long as it's nice and solid, you know, a couple of good extra taps for safety purposes. And then again, if this is one of the ones where you're using screwed up rods that aren't quite the same length, you can put them side by side and only put it in far enough to make them equal. Just make sure that they're nice and solid, which they are. Perfect. So here's one of the changes that I've made. On the original design for this printer, all these pieces were lined up perfectly square. So when your hot end is running up and down on here, as you can see, it sticks out a far amount. So if all these pieces are equal, it means that the closest this can get to the back of the bed is still over an inch away from the back of the bed. So you're losing the entire last inch of the bed by doing that. So what I've recommended doing is offsetting them. That's why we've gone with a 4-inch board here. So by setting these further back, and then we're going to notch into here to allow the bed to move all the way in, we're regaining that inch. And it'll still be able to make it to the front of the bed, because even lined up like this, as you can see, it's making it just about to the front of that piece. So we're going to regain about an inch of building space from that. So that'll be a big benefit. That'll help increase the build volume of this printer substantially. So what we're going to do is we're going to have to assemble our carriage for our x-axis. So what we need is the x-axis carousel, like here. We need the one part of the main part of the hot end mount, not the clip, but the actual part that attaches to the axis itself. One of our modified stepper motors, like that. 2 of our break-off screws, assuming that you've gone with the same size. Your mileage may vary, depending on which ones you're using. 4 of the small bearings. And we're going to need a bunch of the nuts. We're going to need, let's see, 1, 2, 3, 4. We're going to need 8 of them total. So the assembly of this is actually kind of ingenious because it makes it pretty easy to do. Essentially what we're going to do now, his original design calls for the screws to be pushed in from the back, like this, and go through and get through the nuts on here. But unfortunately the heads on my nuts, or on my screws, are a little bit too big, and they would collide with the motor when we're doing the assembly. So I'm reversing that decision, that design decision, and instead I'm going to start off for both of these from the front. So go ahead and push through just like that. So from there, we're going to take one of our nuts for each of them. I'm just throwing stuff around here. And we're going to tighten it down, but not completely tight. From there, on each of them, we're going to drop on 2 of our small bearings. Like that. Then 1 more nut on top of that. Then 1 more nut on top of that one. Just like that. Then our motor is going to get mounted up. And it should line up perfectly, like that. And then finally on top, we're going to go ahead and stick a nut. And at this point, we're going to switch to a screwdriver. And the reason we didn't want to tighten these up too much is because we still want this to be able to free spin. So we can tighten that down. And that's going to pull the motor in nice and flush. At this point, you're going to want to tighten down everything that you can. Now the 2 nuts here should actually be locked against each other, which should prevent any loosening there. So you're mostly concerned about the last one, but just to be safe, tighten the entire assembly down. And you should have these two bearings being able to free spin with each other. And that creates the main part of our axis. So I've gone ahead and mounted it with the wires mounting up because the hot end wires and everything are going to bunch up and go together along with the Bowden tube. That's the ultimate plan here. From there, we should be able to run the belt through it and get the general idea as to how this entire assembly is going to work. So you can see with a setup like this, because it makes the belt make more contact with the pulley, it ends up being contact all the way around it. The belt doesn't have to be as tight, which is better for the motor. You don't want to put too much force on the motor, but it'll still end up holding onto the belt better because over half of the pulley is now touching the belt. And you can see even with just a little bit of force, I can't pull that through easily, so it shouldn't miss steps based on it slipping on there. So now that our hot end carriage is ready to go, we can move on to the next step, which is assembling the rest of the axis. So for this part, we'll be working with our 2 Z guides, and we're going to be putting the smooth rods into one of them. Here you'll want to make sure that the rods that you have are best matched up between them, because again, this is coming back to one where the accuracy of these rods is pretty important. And we'll resort to our sacrificial board once again. Line it up, and we should be able to just tap our smooth rods in. So there's one. Now the second one's always a little bit tricky because you don't want to hit this too hard. So you're going to try and just, worst comes to worst, now with these, you can do the same type of cleanup to make sure that you have no problem getting those rods in. But you're going to want to do less cleanup because you don't want to risk making the rods loose in these, especially since this printer isn't designed to have any support above the top of the Z-axis. So with the rods installed on one side, you're then going to go ahead and install your hot end carriage. And then we're going to put the other end on the carriage. And there we have it. That is one of the main parts of the printer done. And you can see how it's all starting to come together. Now it's time to get all our parts lined up and figure out how big our board's going to have to be. So I did it this way so that, again, you can use any size smooth rod you want. You can experiment, and you should have no problem making this work for you. So you'll position your two Z carriage motor holders on your piece of wood, loosely where they're going to be. And then we're going to take our Z carriage slash hot end system, and we're going to go ahead and slide it straight down onto those rods. And we're going to let it sink right to the bottom. And that's it. You're going to square off your pieces across the back. And that tells you exactly where your board needs to be. There's not really any measuring required. Just keep everything nice and square all the way around. Take whichever marking tool you've got and just draw your line. And it's that simple. So we can now see that the total assembled size of that part of the printer is going to be just over 15.5 inches. So from there, we're going to want to mark off the middle of the system, middle of the board. Our Y carriage is just shy of 4 inches long. So we know that we can measure in from just shy of 2 inches on either side. Line up with those marks, and that is where our y-axis mount is going to be. Now, the one thing we're going to need to do is cut out the wood underneath our motors. This is for two reasons. One, the design is to have the motor sitting flush with this piece here, but number two, it allows for more airflow underneath, which is going to be important because these motors do have a tendency to overheat if you overtax them at all. For the other side, one of the modifications I'm going to make so that we get a little more z-axis, because the hot end hangs down so far from here, as you can see, is that we're going to put additional blocks where these are going to be mounted so that it's actually held up an extra inch above, which will give us a little more usable z height on it. Okay, so next we're going to have to mark off all the spots we need to cut this board. Now we've already marked where our y-axis carriage is going to sit. We'll do the y-axis carriage assembly now. So basically you're just going to toss your bearings into the bearing compartment, and then we're going to use thin cable ties to hold them in place. So I'm using this bag of cable ties I bought at the dollar store. They're pretty basic and pretty much all you're going to need. Just feed them through the slots here. Then back up the other side, and we will just zip tie them just like this. Give it a good tighten down. With all your bearings in place, you can then go ahead and give them a final tighten, and then just use your flush cutters to get rid of the excess. With those in place, we can now install our linear rods, which should slide through there no problem. With our linear rods in place, we can now put the end stops on them so we can mark off where we're going to have to cut the wood to allow the ends of this axis to be able to make it all the way to here. So we'll go ahead and position them like that. And we will position our y-axis carriage exactly where it's supposed to be, and then it's just a matter of sliding it in until it makes contact with the wood. Then we will use a writing implement to notch off the wood, to show where we're going to notch off the wood. To allow that to use up all the space. So up from there, across to there, up from there, and across. So this will allow this to travel all the way to here to give us the maximum amount of usable space on that carriage.
Next, I went ahead and cut the end of the board off with my jigsaw. I did this inside, which I really don't recommend, but again, it was raining that day and I was trying to make sure that I made progress, but later on I learned my lesson and had the shop vac going the entire time for other cuts to keep them as clean as possible.
Next, we're going to want to cut out the riser blocks for our z-axis so that we can raise it up an extra inch and get that extra inch back in our vertical height. So just take your two motor mounts for the z-axis, lay them out on the scrap piece of wood from the end of the one we just cut, and go ahead and mark off their width on the board like that. You can actually just then turn it around and use it to make it the length of the board. Like that. Now, using your cutting implement of choice, either your jigsaw or miter saw or even handsaw, you'll go ahead and cut those two blocks off, and those are going to go on either end of this block to give us the extra height we need. With our two end blocks cut, it doesn't hurt to give it a little bit of a cleanup with either a bit of sanding paper or sanding blocks. Then you're going to pick the best looking side to point up because we're going to be gluing over top. And You can either use clamps if you have a set of clamps, or you can use heavy objects, basically. Anything that's got a bit of weight on it that you can leave sitting on top of it while the glue hardens is going to work out just fine. Take our carpenter's glue, and we're going to smooth a little bit over the wood. Now, this one's been roughed up a bit, but if your wood hasn't been and it's smooth, you can give it a couple of quick brushes with your sandpaper. Creates a bunch of little micro scratches in it, which give the glue something to hold on to. And then line up your pieces. Just like that. So I am just going to weigh one side down with my drill, weigh the other side down with my jigsaw. Once you've positioned your heavy objects on it, if that's the route you're going, make sure that everything's still lined up, because it's super easy for these pieces to shift as you're putting the weight on them. And we're back. It's been about an hour and a half or so, so these should be nice and set at this point. You can see that the glue has actually, where it's leaked out, gone transparent, and those are pretty permanently bonded. Now the next thing we're going to want to do is put feet on this, because we're going to be putting this onto a platform that's going to hold not only the printer but the electronics in the back and the power supply, and hopefully like an Orange Pi or a Raspberry Pi to control the whole system. But because we're going to be putting holes through this to allow ventilation for the motors, like here, here, and here, we're going to want to make sure that this isn't just sitting flat on the platform. So what we're going to want is a piece of wood that'll fit here underneath and here underneath. So you can try and use the remainder of what was left from our piece of wood, which is going to give you small feet. Now it's all pretty solid, and the other change that we're making is in the original design, he has this sitting a far amount, about 3 inches above the platform, and it really doesn't need that much distance. You just need a little breathing room for underneath. So with such a short distance, cutting this in half would probably be sufficient, but I have a backup 1x4 here. So I'm just going to go ahead and I'm saying we want a distance from about there to there. So I'm just going to go ahead and cut one piece off, then use that and create a second one, and then we'll glue that underneath, and that will give us our stand. Now what I've gone ahead and done before I go ahead and glue these is I've drawn a straight line down from the inside of these blocks so that the spacing will be equal on both sides. So we'll go ahead and flip this onto its back, and once again we'll scuff up the surfaces that we're going to be working with to make sure that the glue has enough space to adhere to. And I've got my 2 blocks. Now on his build he had done it kind of like that, so you had that much height underneath it. We're not going to do that. We don't need that much space. So we'll go ahead and mark it like that and like that. We're kind of getting something that looks like an old school Space Invader, really. So with the gluing of these pieces, there's a fair amount of weighting. You could potentially do all the work and glue it all together and then use clamps to hold it all together, so you only have to weight once. But I've got some time on my hands and I've got some other stuff to do, so I'm just going to go ahead and do it piece by piece, and it should work out just fine.
So with our frame assembled, the next thing we're going to need to do is mark off the holes for the Z-axis so we can drill the holes in it for the motors. So we'll position our pieces and then go ahead and attach the Y-axis to that to get them properly into place. And just slide it down there and then get everything positioned up. And then all we need to do is use our pencil to mark off the holes and spacing while holding the pieces in our fingers. Next thing we do is drill holes for pilots for the jigsaw to be able to cut out the part where the bed is going to enter into the frame. Then I used an 1.25 inch spade bit to drill the holes, and using my shop vac clean that up so that we would have holes big enough to drop the motors into. Now this gets it pretty close. After that we're going to need to use something like a rotary tool or a wooden file to size them a little bit bigger and allow for the circuit board part of the motor to fit into the wood as well. So here we are doing the Z-axis. You see there's the spade bit. I would actually recommend using a hole saw versus using the spade bit, but the spade bit is what I had on hand and it works. It's just a lot messier because it chunks away all the wood. And here I am using the rotary tool to mark off and expand the hole so that the hole is big enough to drop the circuit board in. Now here I am using the jigsaw to cut out the hole for the bed to go into, and I would really recommend actually cutting this out before gluing the wood and then use a sanding block or sandpaper to smooth this out. Now you're not going to be able to see this when it's fully assembled, so that part doesn't actually need to be properly and perfectly clean. And here you can just test dropping the motors in to make sure that the holes you've made are adequate and that everything lines up properly. If you've done your job properly, they should just drop in. At this point, I got pretty impatient and pretty excited, so I decided to hook everything up and see if there were signs of life, and sure enough, the Y-axis moved without any problem. It's a little bit slow, but we'll see if we can't tune that. Next, it was time to give it a paint job, so I decided to go with a flat black with the orange parts. I think the black and orange is going to go really, really well. So here I am applying the first light coat. Now you want to go light. It'll dry quickly in between coats versus if you spray it and try to get full coverage in one shot, it can take days. I've even seen it take weeks for the paint to finally dry out because it seals so much moisture under the surface. And here it is, the second coat. You can see it's looking nice and rich and dark. Alrighty, with our paint job nice and dry and ready to go and our holes properly sized, we can now put the parts on top to see how everything is going to fit together and see how the final product is going to look. So I've got my axis still assembled here. So one at a time, you'll have to feed the wires through the holes like this. Now, if you're not lazy like me, you can actually just reassemble this from scratch, which would mean that the pieces would drop in. You wouldn't have to worry about lining the motors up right off the bat, but there's one side. And the other. That fits nice in there. I've got my two clips here holding the axis up because I don't yet have the threaded rods, so I'm making do with what we've got to make sure we don't get slowed down. Next, we're going to drop in parts for our bed. So we have an assembled x-axis, we have an almost assembled y-axis. In the next part we'll get into that. And that gives us our first idea of how this is all going to look together. I'll switch to the front view for the closing comments and you'll get a full view of it, and hopefully we'll have some parts moving back and forth. And that seems like a pretty good place to end part 2. In part 3, we're going to tackle building the bed. We're going to see if it's going to be level enough on its own or if we're going to have to build in leveling with springs. We'll hopefully get the hot end and everything wired. And I'm still waiting on the 5mm threaded rod for the Z-axis. So there's a few more parts yet to come. But I think we're off to a promising start. As you can see, the Y-axis is moving back and forth without any problems. There'll be some fine-tuning once all said and done to see how much speed we can get out of it. But there we have it. I think it's looking pretty good. The black paint job with the orange part seems to go together pretty well. So if you're new here, subscribe so that you're notified when part 3 comes out. If you like this video, thumbs up. If you have any comments or questions about it, toss them in the comments below. I'll do whatever I can to help answer those questions as we go. At the end, I'm going to release the firmware configuration as has been asked by some of you. So it'll be nice and easy for you to get up and going. And part 3 should be out in the next week or so. So until next time, stay creative.